Okay, this is part 3 of section 17.3, acid-base titration. So in this lecture, what I'm going to discuss is the use of what are called acid-base indicators. Acid-base indicators are used throughout chemistry and biology to determine the equivalence point, or approximately to determine the equivalence point of certain reactions. There are many different types of acid-base indicators in existence, and they're based on color changes. So if you look at the figure down below, what you'll see is the color changes that occurs when you add a base to a solution that has the colorant that exists in red cabbage. So if you buy a head of red cabbage and boil it, chop it up and boil it, you can extract out in the water a solution that has an acid-base indicator in it. It changes color as the solution that it's in becomes more basic. So if you take the indicator, in this case from the red cabbage, and you start titrating it with more base, so you're making it more basic, it'll change colors all the way over to the yellow range. Okay, so it'll start off as red, and then so under acidic conditions it'll be red, and then under basic conditions it'll be yellow. So we can use that as an indicator of when a solution is changing from one pH to another. So as I said, there are many of them out there. One common one is called phenolphthalein. Phenolphthalein, if you look up in the figure here, it changes color. It actually, what it does is it goes from being colorless below pH 8 to being pink above pH 8. And so in that range, which is a little bit more than neutral, right? That's just a tad bit above neutral. 8.3 is the indicator here. Once you add the same amount of sodium hydroxide as you have HCl, for example, the pH would be 7 at the equivalence point. Well, just another drop or so of the sodium hydroxide will raise the pH to above 8, and it'll change color. So phenolphthalein is a very good indicator for seeing the changes, the equivalence point, for measuring the equivalence point when that equivalence point occurs near a pH 7. Okay. Now it's important to important to mention that there are two terms that can be mixed up. One is called the equivalence point. And the equivalence point is when the moles of the acid that are in the titration is equal to the moles of the base. But there's another term that you may see called the end point. And the end point is when the indicator changes color. So for example, with phenolphthalein, although the equivalence point for the titration of HCl and NaOH would be pH 7, the end point is at pH 8, a little bit above 8 according to this diagram. So they're not exactly the same, right? They're close, but they're not exactly the same. Well, it turns out that 8.3 is close enough to 7 that it's really just off a drop or so. So it's really pretty close. If you take a look at methyl red would not be a good indicator to use for that particular titration between HCl and NaOH, because at the equivalence point, that reaction changes pH at 7, but this one changes color at pH 4. That's way off from 7, so that's not a good indicator for that. However, it might be a good indicator for a strong acid with a weak base, because the equivalence point of a strong acid with a weak base is less than 7. And the range here that's indicated is between 4.2 and 6.3. Okay? Now, if you take a look at that top curve, you'll see, at the top figure, you'll see that these are actually titration curves, right? And these are for the indicators. It's showing where the indicators change color. And it turns out indicators are really essentially weak acids. And so I won't go into their structures. They're generally pretty complicated organic compounds. But indicators are essentially weak acids. And so when you dissolve them in water, they'll react with, for example, sodium hydroxide. And when they do, let me put an N here. It's not HI, it's HNIN for indicator. You'll get the sodium indicator, the indicator conjugate base, and then you'll get water. So essentially what happens, this is the conjugate base, is in order for a molecule to act as an acid-base indicator, the color of the weak acid has to be different from the color of the conjugate base. So as you add sodium hydroxide, this reaction occurs, and as that reaction occurs, it changes color. Now typically what you would do is in the reaction flask or in a beaker or a coffee cup, you would put your solution in there, maybe put the acid solution in there, and you would titrate with the basic solution, for example, sodium hydroxide. And then you would just put a drop or two of the indicator in there. Usually a very low concentration. Our eyes are very sensitive to color, so you don't really need very much of it. And what will happen is the base will react with the acid, okay? And then once the acid is completely used up, once it's down to zero, it's all been reacted, then the base will start reacting with the indicator and it will change the color of the indicator. And then you can stop the titration. Okay? So if we wanted to pick an indicator, we'll take a look at a sample problem where you get a choice of which indicator you want to pick for what reaction.